The time period of a simple pendulum refers to the time it takes for the pendulum to complete one full swing or oscillation back and forth. It depends on the length of the pendulum and the acceleration due to gravity, but not on the mass of the pendulum bob. This concept is a fundamental part of physics, demonstrating the principles of periodic motion and harmonic oscillation. Definition of ideal simple pendulum: a heavy point mass suspended by a light inextensible string or thread is called an ideal simple pendulum. In reality, achieving an ideal simple pendulum is not possible. A small metal sphere called a bob suspended from a rigid support using a cotton thread is taken as a simple pendulum. An ideal simple pendulum is a theoretical concept used in physics to study the motion of a pendulum in its simplest form. By ignoring factors like air resistance and the string's mass, let's break it down to explain it clearly. Heavy point mass. This means we imagine all its mass is concentrated at a single point. In reality, pendulum bobs have some size, but for simplicity in calculations we ignore this and treat it as a small dense object. Light string or thread. The string that suspends the pendulum is assumed to be very light, negligible mass. This is important because if the string had significant mass, it would also contribute to the motion, complicating the calculations. Inextensible string. The string cannot stretch. Its length remains constant during the pendulum's motion. This ensures that the pendulum swings in a predictable arc without changing its path. No air resistance or friction. In an ideal pendulum, we assume there's no air resistance or friction at the point of suspension. This means the pendulum can swing forever without slowing down, which is not possible in real life. Let's study some basic definitions. Point of suspension. The point from which the bob is suspended is called the point of suspension. In figure, point O is called point of suspension. Length of the pendulum. The distance between the point of suspension and the center of bob is called the length of the pendulum. See the figure. The distance from point O to the center of the bob is called length of the pendulum. Derivation or expression for time period of simple pendulum. A pendulum of length L is suspended from a fixed support O. Let m be the mass of the bob. If the bob is slightly displaced and released, it starts oscillating. At position A, the weight mg of the bob acts vertically downward and the tension T in the string balances it. When the bob is at position B, during its oscillation, the weight mg acts vertically downward. This weight can be resolved into two components. mg cos theta acts along the string and is balanced by the tension T. mg sin theta acts tangential to the displacement and tries to bring the bob back to its mean position A. This mg sin theta is called the restoring force. The restoring force is given by F is equal to minus mg sin theta. The negative sign indicates that the force is opposite to the displacement. If theta is small, sin theta is approximately equal to theta. Therefore, F is equal to minus mg theta. The angle theta can be determined by observing the figure. In triangle OBA, sin theta is equal to y by L. If theta is small, sin theta can be approximated as theta. Therefore, theta is equal to y by L. Force F is equal to minus mg into y by L. Acceleration A is equal to F by m according to Newton's second law. Therefore, acceleration A is equal to minus g by L into y. We know the equation of acceleration of a body in simple harmonic motion is A is equal to minus omega square y. Comparing, we get omega is equal to square root of g by L. Time period of oscillation t is equal to 2 pi by omega. Substitute the value of omega, we get t is equal to 2 pi square root of L by g. This is the equation for time period of simple pendulum. Thanks for watching Pathfinder 6. Like, comment, share and subscribe to my channel.